So nodri. So welcome to the session. Now we shall solve the problems based on the chapter thermodynamics. First question what they asked is, so a geyser heats water flowing at the rate of 3 liters per minute from 27 degrees Celsius to 77 degrees Celsius. So if the geyser operates on a gas burner, what is the rate of consumption of the fuel if its heat of combustion is 4 into 10 to the power of 4 joules per grams anta kelidara. So here from the question, so what they have given, nodri. Water is flowing at the rate of 3 liters per minute ಕೊಟ್ಟಿದ್ದಾರಾ. So these are the givens. So from the question what they have given, water is flowing at the rate of 3 liters per minute. The glycerin heats the water, rising the temperature from 27 degrees Celsius to 77 degrees Celsius. Initial temperature, final temperature, change in temperature they have given. Heat of combustion they have given, specific heat of water and mass flowing water M value they have given, and total heat used. So from the question, so read the question, try to understand that one. So from the question, water is flowing at the rate of 3 liters per minute and geyser heats the water, rising the temperature from 27 degrees Celsius to 77 degrees Celsius. Initial temperature T1 they have given 27 degrees Celsius, final temperature T2 ಅಂತ ಹೋಗ್ತೀವಿ, that is 77 degrees Celsius. Rise in temperature delta T is equal to T2 minus of T1. ಅದನ್ನ ಡಿಫ್ರೆನ್ಸ್ ತೆಗಿರಿ, 77 ಮೈನಸ್ ಆಫ್ 27 ಮಾಡಿದ್ರೆ 50 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಬರುತ್ತೆ. ಸೊ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಆಫ್ ವಾಟರ್ 4.2 ಜೋಲ್ಸ್ ಪರ್ ಗ್ರಾಮ್ಸ್ ಪರ್ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಮಾಸ್ ಆಫ್ ಫ್ಲೋಯಿಂಗ್ ವಾಟರ್ ಎಮ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 3 ಲೀಟರ್ ಪರ್ ಮಿನಿಟ್, ಅದನ್ನು ಗ್ರಾಮ್ ಪರ್ ಮಿನಿಟ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 3000 ಆಗುತ್ತೆ. So total heat used is calculated by using formula delta Q is equal to mass into specific heat into delta T ಮಾಡ್ತೀವಿ. So here substitute all the given values. So after substituting, so what the value we are getting, let us see. ಏನ್ ಕೊಟ್ಟಿದಾರ, so by using given data, total heat, so that is calculated by using formula. So delta Q is equal to mass into specific heat into delta T. So ಇದೇ value na ಇದನ್ನೇ ಏನ total heat used is calculated by using formula delta Q is equal to mass into specific heat into delta T. ಅದನ್ನೇ ವ್ಯಾಲ್ಯೂ ಎಲ್ಲ ನೋನ್ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ರಿ. ಸೊ ಮಾಸ್ ಎಷ್ಟೈತಿ, ಸೊ ದಟ್ ಈಸ್ 3000 grams per minute ಐತಿ. ಸೊ ಅದನ್ನ ಗ್ರಾಮ್ಸ್ ಒಳಗಾರು ತಗೋಬಹುದು, ಲೀಟರ್ಸ್ ಒಳಗ ತಗೋಬಹುದು. ಅಂಡ್ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಆಫ್ ವಾಟರ್ ಈಸ್ 4.2, ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡೀನಿ. ಅಂಡ್ ಡೆಲ್ಟಾ ಟಿ ವ್ಯಾಲ್ಯೂ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ದಟ್ ಒನ್ ಆಸ್ 50, ಇಲ್ಲಿ ಆಲ್ರೆಡಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. ಸೊ ಎಲ್ಲಾ ನೋನ್ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 6.3 into 10 to the power of 5 joules per minute ಬಂತು. So therefore, and the rate of consumption is calculated by 6.3 into 10 to the power of 5 divided by 4 into 10 to the power of 4 ಮಾಡಿದಾಗ rate of consumption ಎಷ್ಟು ಬಂತು, 15.75 grams per minute ಅಂತ ಬಂತು. So I hope you got this one. So first ನಾವೇನ್ ಮಾಡಿವಿ, given ಬರ್ದಿದ್ದೀವಿ, ಆಮೇಲೆ total heat used is calculated by using formula delta Q is equal to mass into specific heat into change in temperature, ಎಲ್ಲಾ values ಅನ್ನು substitution ಮಾಡಿ Rate of consumption, we got that one as 15.75 grams per minute bantu. So this is the solution for that is first problem. So what is second one? Let us see. No, second problem in kottidara. So second problem is what amount of heat must be supplied to 2 into 10 to the power of minus 2 kg of nitrogen at room temperature to rise its temperature by 45 degrees Celsius at constant temperature అని కొట్టిదారా. So molecular mass of nitrogen 28 అని కొట్టిదారా. Universal gas constant is 8.3 into 8.3 joules per mole per Kelvin ಅಂತ ಕೊಟ್ಟಿದಾರಾ. So we have to calculate amount of heat supplied. They are already given, and to rise the temperature by 45 degrees Celsius at constant temperature, we have to calculate that one. So let us see how to solve this one. So here from the question what they have given is so here they have given mass of nitrogen they have given, and rising temperature delta T they have given, molecular mass of nitrogen they have given, universal gas constant that is constant value, number of moles that is given by the formula. So that is written as, so N is equal to number of moles is given by N is equal to small m divided by capital M it is. So after simplification number of moles we got that one as 0.71. And molar specific heat of constant pressure of nitrogen is given by Cp is equal to 7 by 2 into specific heat capacity, that is universal gas constant, and we got this one as 29.05 joules per mole per Kelvin. And here by using these, total amount of heat to be supplied is given by the formula delta Q is equal to N into Cp into delta T. So here substitute all values 0.714 into 29.05 into 45. So therefore delta Q value we got 933.38 joules. So this is the solution. So here what they have given, note from the question mass of nitrogen M value they have given, that is 2 into 10 to the power of minus 2 kg. ಅದನ್ನ ನಾವೇನ್ ಮಾಡಿವಿ kg ನ grams ಗೆ convert ಮಾಡಿವಿ. delta T value ಕೊಟ್ಟಿದಾರ. ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ, mass of nitrogen M is 2 into 10 to the power of minus 2 kg. ಅದನ್ನ grams ಗೆ convert ಮಾಡಿ 20 grams ಬಂತು. Rise in temperature delta T value 45 degrees Celsius ಕೊಟ್ಟಿದ್ದಾರೆ. Molecular mass of nitrogen they have given, that is M is equal to 28. Universal gas constant that is always constant, that is R is equal to 8.3 joules per mole per Kelvin. Number of moles is calculated by using formula small m divided by capital M. Small m value already, that is 2 into 10 to the power of minus 2 already mail question ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. divided by, so that is molecular mass of nitrogen is 28. ಅದನ್ನ ಹಾಕಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ 0.714 ಬಂತು. That is number of moles it is. Next, molar specific heat at constant pressure for nitrogen is given by the formula CP under specific heat at constant pressure, that is given by 7/2 into R. 7/2 is constant, R is universal gas constant, 7/2 is, so that is constant value, universal gas constant value is 8.3 ಬಂತು, ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ. So ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ molar specific heat at constant pressure for nitrogen we got 29.05 joules per mole per Kelvin. And the total amount of heat to be supplied ಎಷ್ಟು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರ delta Q is equal to N into specific heat at constant pressure into change in temperature ಮಾಡಿದಾಗ. So here N value means N ಅಂದ್ರೆ ಇಲ್ಲಿ number of moles, CP under specific heat at constant pressure for nitrogen, delta T is change in temperature, substitute all the known values and we got delta Q value as 933.38 joules ಬರುತ್ತೆ. So ಇಲ್ಲೆಲ್ಲ known values ನೀವು substitution, N value substitution ಮಾಡಿ, CP value substitution ಮಾಡಿ, ಆಮೇಲೆ delta T value ನು substitution ಮಾಡಿದಾಗ we got delta Q value this much of value. Next, we shall move to next question. So 12.3 it is theoretical one. So go through it and try to solve yourself. Next, we shall see 12.4. ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡ್ರಿ. So what they have given is a cylinder with a movable piston. It contains 3 moles of hydrogen at a standard temperature and pressure. Walls of the cylinder are made of heat insulator and the piston is insulated by having a pile of sand on it. By what factor does the pressure of the gas increases if the gas is compressed to half its original value anta kelidara. So let us see how to solve this one. So from the question, so first we have to write what are the given things. So we know so here the cylinder is completely insulated from its surrounding. As a result, no heat is exchanged between the system and the surrounding cylinder and the surrounding. Thus process is yaudidu adiabatic. Therefore, so they have given from the given things initial pressure na P1 ಅಂತ ತಗೊಳ್ಳೋಣ, final pressure of the cylinder P2, initial volume inside the cylinder let us consider V1, final volume of the cylinder is V2, ratio of specific heat gamma is equal to 1.4. For adiabatic process we have the relation P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So therefore final volume is compressed to half its initial volume andra V2 is equal to V1 by V1 by 2 ಅಂತ ಬರಿಬೋದಾ. ಇದೇ ರಿಲೇಷನ್ ಯಾವ ತರ ಬರಿತೀನಿ, so it is also written as like this, ಏನೋ half of initial one, ಅದನ್ನ ಹೆಂಗ್ ಬರಿಬೋದು, P1 V1 raised to gamma is equal to P2 into ಇದು V2 ಅಂದ್ರೆ it is reduced to half, ಅದಕ್ಕೆ V1 by 2 whole raised to gamma ಅಂತ ಬರುತ್ತೆ. So P terms ಒಂದ್ ಕಡೆ ಮಾಡ್ಕೊಳ್ರಿ. So P2 divided by P1. ಇದನ್ನ ಈ ಕಡೆ ಅಂದ್ರೆ P1 ಟರ್ಮ್ಸ್ ಒಂದ್ ಕಡೆ ಮಾಡ್ಕೊಳ್ರಿ, ರಿಮೈನಿಂಗ್ ಟರ್ಮ್ಸ್ ಅನ್ನು ಒಂದ್ ಕಡೆ ಮಾಡ್ಕೊಳ್ರಿ. ಸೊ ರೇಸ್ ಟು ಗಾಮಾ ಹೋಲ್ ಡಿವೈಡೆಡ್ ಬೈ, ಸೊ V2 ಅಂದ್ರೆ V1/2 ಹೋಲ್ ರೇಸ್ ಟು ಗಾಮಾ. ಸೊ ನೋಡ್ರಿ ಎರಡಕ್ಕೂ ಗಾಮಾನ ಏನ ಕಾಮನ್ ಐತಿ. ಇದನ್ನ ಯಾವ ತರ ಬರಿಬಹುದು, ಇದನ್ನ ಹೆಂಗ್ ಬರದ್ರಿ ಅಂತಂದ್ರ, ಸೊ V1 ರೇಸ್ ಟು ಗಾಮಾ ಎರಡಕ್ಕೂ ಕಾಮನ್ ಐತಾ, ರೇಸ್ ಟು ಗಾಮಾ ಡಿವೈಡೆಡ್ ಬೈ ಇದು V1 ರೇಸ್ ಟು ಗಾಮಾ. ಈ 2 ಇದ್ದದನ್ನ ಇಲ್ಲಿ ಮೇಲೆ ತಗೊಂಡ್ ಬರ್ತೀನಿ ನಾನು, ಇದಕ್ಕೂ ಕೂಡ ಗಾಮಾ ಅಪ್ಲೈ ಆಗ. ಸೊ ಇದು ಗೆಟ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗಿ 2 ರೇಸ್ ಟು ಗಾಮಾ ಬಂದ್ರೆ, ಸೊ 2 ರೇಸ್ ಟು ಗಾಮಾ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು 1.4. ಸೊ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 2.639 ಬಂತು. ಸೊ ಪ್ರೆಷರ್ P2 by P1. So the pressure increased by the factor of 2.639 ಬಂತು. ಸೊ ಇಲ್ಲಿ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡ್ರಿ, ಇನಿಷಿಯಲ್ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ಸಿಲಿಂಡರ್ ನ P1 ಅಂತ ತಗೊಂಡಿನಿ, P2 ನ ಫೈನಲ್ ಪ್ರೆಷರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿವಿ. ಇನಿಷಿಯಲ್ ವಾಲ್ಯೂಮ್ ಅನ್ನ V1 ಅಂತ ತಗೊಂಡಿವಿ, ಫೈನಲ್ ವಾಲ್ಯೂಮ್ ಅನ್ನ V2 ಅಂತ ತಗೊಳ್ಳೋಣ. ಸ್ಪೆಸಿಫಿಕ್ ರೇಷಿಯೋ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ನ ಗಾಮಾ 1.4 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಫಾರ್ ಅಡಿಯಾಬೆಟಿಕ್ ಪ್ರಾಸೆಸ್ P1 V1 ರೇಸ್ ಟು ಗಾಮಾ ಇಸ್ ಈಕ್ವಲ್ ಟು P2 V2 ರೇಸ್ ಟು ಗಾಮಾ ಅಂತ ಬರಿಬಹುದಾ. ಸೊ ಅವ್ರ ಏನ್ ಕೊಟ್ಟಾರ, ಫೈನಲ್ ವಾಲ್ಯೂಮ್ ಇಸ್ ಕಾಂಪ್ರೆಸ್ ಟು ಹಾಫ್ ಆಫ್ ಇಟ್ಸ್ ಇನಿಷಿಯಲ್ ವಾಲ್ಯೂಮ್ ಅಂತ ಕೇಳಿದಾರೆ. ಸೊ V2 ಇಸ್ ಈಕ್ವಲ್ ಟು V1/2 ಅಂತ ಬರಿಬಹುದಾ. ಸೊ ಅದನ್ನೇ P1 V1 ರೇಸ್ ಟು ಗಾಮಾ ಇಸ್ ಈಕ್ವಲ್ ಟು P2 V2 is reduced to half ಅಂದ್ರೆ V1/V2 ರೇಸ್ ಟು ಗಾಮಾ ಆಸ್ ಇಟ್ ಇಸ್. ಪ್ರೆಷರ್ ಟರ್ಮ್ ಒಂದ್ ಕಡೆ ಮಾಡ್ಕೊಂಡಿನಿ, ವಾಲ್ಯೂಮ್ ಟರ್ಮ್ ಒಂದ್ ಕಡೆ ಮಾಡ್ಕೊಂಡಿನಿ, ಅಂಡ್ so those are same term get cancelled with each other and we got 2 raised to 1.4 ಅಂದ್ರೆ that is P2 by P1 value ಎಷ್ಟು ಬಂತು ನಮಗೆ 2.639 ಬಂತು. So this is the solution. So next we shall see next one. ನೋಡ್ರಿ 12.5. Go through the question and try to understand that one. So ಏನ್ ಕೇಳಿದಾರ ಅವರು, in changing the state of a gas adiabatically from an equilibrium state A to another equilibrium state B, an amount of work equal to 22.3 joules is done on the system. If the gas is taken from state A to B via a process in which net heat absorbed by the system is 9.35 calorie, how much is the net work done by the system in the later case ಅಂತ ಕೇಳಿದ್ದಾರೆ. So 1 calorie value already ಕೊಟ್ಟಾರ 4.19 joules ಅಂತ already they have given. So let us see how to solve this one. So we know the work done on the system while the gas changes from A to B is 22.3 joules. So this is the adiabatic process, hence change in heat is 0. ಅದಕ್ಕೋಸ್ಕರ ನಾವೇನ್ ಬರೀತೀವಿ ಅದನ್ನ delta Q is equal to 0 ಅಂತ ಬರೆದ್ವಾ. So work done delta W is equal to minus 22.3 joules. Since work done on the system ಅದಕ್ಕೆ negative ತಗೊಂಡಿವಿ. So from first law of thermodynamics we are writing the formula delta Q is equal to delta U plus of delta W. Delta U ಅಂದ್ರೆ ಏನು, nothing but change in internal energy. Delta U is nothing but delta Q minus of delta W ಅಂತ ಬರಿಬಹುದು. and delta U again ಬರುತ್ತೆ value 22.3 joules ಬಂತು. So when the gas goes from A to B via process, net heat absorbed by the system that is given by the formula delta Q, heat absorbed. So delta Q is equal to 9.35 calorie. So ಇದನ್ನ 1 calorie value ಅವರು ಕೊಟ್ಟಿದ್ದಾರೆ 9.35 as it is ಇಟ್ಟಿನಿ 1 calorie value ಎಷ್ಟು 4.19 ಇದನ್ನ ಹೇಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 39.175 joules ಅಂತ ಬಂತು. So this is delta Q value ಬಂತು. So next heat absorbed. Heat absorbed is given by the formula delta Q is equal to delta U plus of delta Q. Or work done, change in work done is given by delta Q so work done is given by delta Q minus of delta U ಅಂತ ಬರಿಬೋದಾ ಇದನ್ನ. So ಇದನ್ನ ಏನ್ ಮಾಡ್ರಿ ಆ known values delta Q value ಎಷ್ಟು 39 delta Q already calculate ಮಾಡಿವಿ. Delta Q value ಎಷ್ಟು 39.1765 minus of delta U value ಏನೈತಿ ಇಲ್ಲಿ ಆಲ್ರೆಡಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿವಿ ಇದು delta Q value ಎರಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ರಿ 22.3. So ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ delta W is equal to work done by the system ಎಷ್ಟು ಬರುತ್ತೆ 16.8765 joules ಬರುತ್ತೆ. So here delta Q value is to delta U value is 22.3 delta Q value so 39.17 work done ನಮಗೆ ಎಷ್ಟು ಬಂತು 16.8765 joules ಅಂತ ಬಂತು. So this is the solution for 12.5. And 12.6 is based on theory concept. Try to answer yourself. And let us see 12.7. So ನೋಡ್ರಿ 12.7 ಏನ್ ಕೇಳಿದಾರೆ ಅಂದ್ರೆ a steam engine delivers 5.4 into 10 to the power of 8 joules of work per minute and serves 3.6 into 10 to the power of 9 joules of heat per minute from its boiler. What is the efficiency of the engine? How much heat is wasted per minute anta kelidara. So let us see how to solve this one. 12.7 it is. So here work done by the steam engine per minute from the question they have given. So that is W they have given or they have given W value they have given. Heat supplied from the boiler they have given. Efficiency is calculated for the engine that is output energy divided by input energy. Hence, percentage efficiency of the engine is 15%. Amount of heat wasted is calculated by taking the difference. So therefore, so amount of heat wasted per minute is, we got that is 3.06. Nodri, it is very easy also. So, first try to write the given things, that is work done by the steam engine per minute, W and only, that is 5.4 into 10 to the power of 8 joules, and heat supplied from the boiler, H is equal to 3.6 into 10 to the power of 9 joules. Efficiency of heat engine is calculated by using formula output energy divided by input energy. And efficiency of the engine is denoted by neta is equal to W divided by H. W value already known, that is 5.4, and heat supplied from the boiler, H value is 3.6 into 10 to the power of 9. So after simplification, efficiency of heat engine we got 0.15. ಅದನ್ನ percentage ಒಳಗೆ ಇಟ್ವಿ ಅಂದ್ರೆ 15% ಆಗುತ್ತೆ. Amount of heat wasted is calculated by taking the difference of, that is 3.6 minus of 5.4. So 5.4 under W, 3.6 under heat supply to the boiler. So we got that one as 30.6 into 10 to the power of 8. ಅಲ್ಲಿ digit shift ಮಾಡಿದಾಗ 10 to the power of 9 ಒಳಗೆ ಇಡಬಹುದು. Therefore, heat wasted per minute ಎಷ್ಟು ಬರುತ್ತೆ? 3.06 into 10 to the power of 9 joules ಅಂತ ಬಂತು. So ಇಲ್ಲಿ ನೋಡ್ರಿ, so 3.6 ಅಂದ್ರೆ ಏನದು? H. 5.4 is nothing but W. So amount of heat wasted is 3.06 into 10 to the power of 9 joules. ಇಲ್ಲಿ 30.6 ಇದ್ದದನ್ನ 1 digit ಅಂದ್ರೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ದೀನಿ, ಅದಕ್ಕೆ 10 to the power of 9. 8 ಇದ್ದಿದ್ದೇನಾಯ್ತು? 9 ಆಯ್ತು, ಪವರ್ ನ ಶಿಫ್ಟ್ ಮಾಡಿ. So this is a W divided by H. Got this one? So, okay, well, next we shall move to next one. That is 12.8. Nodri, 12.8 ಏನೈತಿ question? So 12.8, they ask the question like this. So 12.8 it is. What they asked, an electric heater supplies heat to a system at a rate of 100 watt. If system performs work at a rate of 75 joules per second, at what rate is the internal energy increasing? Anta question kelidara. So let us see how to solve this one. So here from the question they have given heat is supplied to the system at the rate of 100 watt. Heat supplied in the Q anta tagontivi. So that is 100 joules per second. System performs at the rate of 75 joules per second. So here heat supplied Q kottidara, system performs at the rate of 75 joules per second adra. So work done W is equal to 75 joules per second anta gottili. So from first law of thermodynamics, from first law of thermodynamics, ನಮ್ಗೆ ಗೊತ್ತೈತಿ ಯಾವ ತರ ಬರಿತೀವಿ? So we have the formula Q is equal to U plus of W. ಹೌದಾ? U ಅಂದ್ರೆ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ. ಸೊ ನಮಗೆ U ಬೇಕಂತಂದ್ರೆ ಯಾವ ತರ ಮಾಡಿಫೈ ಮಾಡ್ತೀರಿ? ಇದೇ ಫಾರ್ಮುಲಾ ಇಂದ U is equal to Q minus of W ಅಂತ ಬರಿಬೋದಾ? ಸೊ ಆಲ್ರೆಡಿ ನಮ್ಗೆ ಗೊತ್ತೈತಿ Q ವ್ಯಾಲ್ಯೂ 100 ಐತಿ, W ವ್ಯಾಲ್ಯೂ 75 ಐತಿ. ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 100 minus 75 ಅಂದ್ರೆ 25 joules per second. This is nothing but work done anta tagotivi. So therefore internal energy of the given electrical heater increases at the rate of 25 internal energy watt. It is at the rate of 25 it is. So this is the solution for 12.8 it is. So this is very easy. Just by using first law of thermodynamics, we are calculating the internal energy. So next one, that is 12.9 it is. So 12.9, what they asked the question? 12.9. A thermodynamic system is taken from the original state to an intermediate state by the linear process that is shown in this diagram. So the graph is, or if the diagram is plotted versus pressure versus volume. So this is pressure and in this it is volume is plotted. So its volume is reduced to original value from E to F by an isobaric process. Calculate the total work done by the gas from D to E to F ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಇಲ್ಲಿ ನೋಡ್ರಿ, so this is the value 2 and this is the value 5 and this is E and this is the D and this value is 600 here and this is 300. So pressure is plotted along y-axis and volume is plotted along x-axis, and this is the origin here and this point is F here and the direction are shown here and it looks like a triangle here. So here in a thermodynamic system is taken from original state to intermediate state by linear process on the diagram kottidare. So its volume is then reduced to original value from E to F by an isobaric process. Calculate the total work done by the gas from D to E. First get D to E, ಆಮೇಲೆ E to F. What is the work done ಅಂತ calculate ಮಾಡಂತ ಹೇಳ್ಯಾರ. So how we are going to calculate this one? Total work done by gas from total work done by gas from D to E and E to F, that is given by ಏನಂತ ಗೊತ್ತೀವಿ, area of the triangle DEF. already ನಾನು ತೋರಿಸಿನಿ DEF and this triangle ಅದರ area ಅಂತ ಗೊತ್ತೀವಿ. So that is area of the triangle DEF ಅಂದ್ರೆ ಯಾವ ತರ ಬರೀಬಹುದು, that is half DE into EF ಅಂತ ಬರೀಬಹುದಾ? ಯಾಕಂದ್ರೆ ಟ್ರಯಾಂಗಲ್ ಅಂದ್ರೆ half DE into EF ಅಂತ ತಗೋಬೇಕು. That is area of the triangle it is. And where DF ಅಂದ್ರೆ ಏನಲ್ಲೇ, so DF is nothing but change in pressure. ಇದು ಇಲ್ಲಿ ನೋಡ್ರಿ, change in pressure, this is nothing but change in pressure. ಅದಂತೂ ಆ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲೇ ಶೋ ಮಾಡೈತಿ. ಅದು ಎಷ್ಟೈತಿ, ಚೇಂಜ್ ಇನ್ ಪ್ರೆಷರ್ ಅಂದ್ರ 600 ಮೈನಸ್ ಆಫ್ 300 ಮಾಡ್ತೀವ. ಸೊ DF is nothing but change in pressure. So that is given by, so change in pressure higher value ಎಷ್ಟೈತಿ 600 Newton per meter square ಐತಿ, lower value 300 Newton per meter square. Difference ಎಷ್ಟು ಬರುತ್ತೆ ನಮಗ, 600 minus 300 ಅಂದ್ರೆ 300 Newton per meter square ಬಂತು. So FE is nothing but, so FE ಇದಕ್ಕೆ ಏನಂತ ತಗೊಂತೀವಿ, ಇದು change in volume ಅಂತ ಅಂತೀವಿ. So that is nothing but change in volume. So ಎಷ್ಟೈತಿ ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ 5 ಐತಿ, ಲೋವರ್ ವ್ಯಾಲ್ಯೂ 2 ಐತಿ. ಅಂದ್ರೆ 5 ಮೈನಸ್ ಆಫ್ 2 ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬಂತು 3 ಮೀಟರ್ ಕ್ಯೂಬ್. ವಾಲ್ಯೂಮ್ ಅನ್ನ ಮೀಟರ್ ಕ್ಯೂಬ್ ಆಗಿ ತಗೊಂತೀವಿ. ನೆಕ್ಸ್ಟ್ area of triangle DEF is calculated by using formula half. DE ಅಂದ್ರೆ ಏನೈತಿ, that is 300. EF ಅಂದ್ರೆ ಏನೈತಿ, that is nothing but 3. So ಎರಡು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ 450 joules ಬಂತು. So that is total work done by the gas from D to E and E to F is 450 joules. It's very easy. ಈ ತರ ಪ್ರಾಬ್ಲಮ್ ಡೆಫಿನೆಟ್ಲಿ ದೇ ವಿಲ್ ಆಸ್ಕ್ ಒನ್. ಸೊ CET ಅಲ್ಲಿನೂ ಇದನ್ನ ಕೇಳ್ತಾರೆ, ಎಕ್ಸಾಮಿನೇಷನ್ ಅಲ್ಲಿ ಕೂಡ ಕೇಳಿರ್ತಾರೆ. ಸೊ ದಿಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಡೆಫಿನೆಟ್ಲಿ ಒನ್ ಪ್ರಾಬ್ಲಮ್ ಲೈಕ್ ದಿಸ್ ದೇ ವಿಲ್ ಆಸ್ಕ್. ಸೊ ನೋಡ್ರಿ ಡಯಾಗ್ರಾಮ್ ಎಲ್ಲ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಟ್ ಈಸ್ ವೆರಿ ಈಸಿ. ಆ ಟ್ರಯಾಂಗಲ್ ಅಲ್ಲಿ ಸೊ ಏರಿಯಾ ಆಫ್ ದ ಟ್ರಯಾಂಗಲ್ DEF ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ ಹೇಳ್ಯಾರ. ಸೊ ಹಾಫ್ ಇಂಟು DE ಇಂಟು EF. DE ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ, EF ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿವಿ. EF is nothing but that is change in volume. So DF that represents change in pressure. After calculating those, so we got area of triangle DEF that is calculated by using formula half DE into EF, and we got that value as 450 joules anta bantu. So this is one of the important question. Definitely they will ask like this one. So got this one. Okay, next we shall move to next problem. ನೋಡಿ next 12.10 in care or question. Refrigerator is maintained, heat tables kept inside at 9 degrees Celsius. If room temperature is 30 degrees Celsius, calculate the efficient of performance anta kelidara. So in a refrigerator it is maintain heatable kept inside 9 degrees Celsius. If room temperature is 36 degrees Celsius ittandra, so calculate the coefficient of performance anta helidare. So coefficient of performance, let us solve that one. So coefficient of performance is calculated by using formula T1 divided by T2 minus of T1. So here from the question what they have given, so they have given temperature inside the refrigerator T1 is 9 degrees Celsius. Adana Kelvin convert madidre 282 bantu. Room temperature T2 is 36 degrees Celsius iddidinda Kelvin convert ಮಾಡ್ತೀವಿ 309 bantu. Coefficient of performance is given by the formula T1 minus T1 divided by T2 minus of T1. So T1 ಅಂದ್ರೆ ಎಷ್ಟೈತಿ, ಇದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ. T2 ಅಂದ್ರೆ ಇದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ. So that's equal to T1 ಎಷ್ಟೈತಿ 282 divided by T2 andra 309 minus of T1 andra 282. ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ 10.44 ಅಂತ ಬಂತು. Therefore coefficient of performance is of the refrigerator value is 10.448. So just ನೀವು ಒಂದು ಫಾರ್ಮುಲಾ ನೆನಪಿಟ್ರೆ ಸಾಕು. That is coefficient of performance is given by the formula T1 divided by T2 minus of T1. T1 value is 282 and T2 value is 309, and substitute those values, and after simplification we got that one as 10.441. That is the value of coefficient of performance. So all the problems in this chapter are very easy. Try to practice those. So if you are having any doubt, put in the chat box.